Hello students, so today we are jumping into different kinds of equations. We're going to be talking about exponential equations. So we're going to be able to solve simple exponential equations using the laws of exponents, which you learned in 8th grade. So you should have a little handout in front of you that you picked up or teacher passed out to you. Or it's also going to be on Canvas. Let me find it so that I can show you what it looks like. So here's the sheet. This is one half of it. So these are all the laws of exponents. These are all the different rules that we'll use. And then I do not expect you to memorize these at all. Maybe you memorize a few because you'll see them a lot on your homework, but none of these, you are not expected to know these. You'll have this on the test. This is just a list of different exponents that we can have, okay? So have that in front of you so that as we're going through the lesson, you know what I'm talking about, okay? Let's start with reviewing the laws of exponents. So in this first one, I have k to the negative 9th power. This is going to be the negative rule on your half sheet that you should have in front of you. When we have a negative exponent, that is the same as 1 over that base and exponent, but now positive. So k to the negative 9th is the same as 1 over k to the 9th. Okay, f to the 7th power times f to the 3rd power. When we have the same base, the f and the f, this is the product rule. Product rule being it's multiplying. When I'm multiplying two bases together, that is the same as adding the exponents together. So f to the 7th times f to the 3rd would be f to the 7 plus 3 is 10. H to the 0 power, that is the 0 rule. Anything to the 0 power equals 1. Anything. A million to the 0 power equals 1. X to the 0 power equals 1. Anything. Okay? Let's see. This one is the power of a product rule. What ends up happening is we kind of distribute the power into the parentheses. And when I say distribute, I mean we have 5b to the 3rd. It's going to be 5 to the 3rd, b to the 3rd. And I can simplify 5 to the 3rd. I'm going to flip my half sheet over. 5 to the 3rd is 125. And that's as far as I can simplify b because I don't know what b is. So 5b to the 3rd power is 125b to the 3rd power. Okay. R over s to the 4th is the same as r to the 4th over s to the 4th. So same distributing thing, but it's power of a quotient now because it's over a fraction. Fractional exponents. So when I have a fractional exponent, I actually have w, I have a root, and whatever the root is, that's the bottom. So little 4, and then my 3 is the power. So it'd be w to the 3rd power, and then the 4th root of that. That is fractional exponents. So that's just writing it differently. Okay. A to the 6th over a to the 4th, that's the quotient rule on your page. What ends up happening is we subtract the 6 and the 4. So a to the 6th over a to the 4 becomes a to the 6 minus 4 is 2. V to the 6th power to the 3rd power. This is your power of a power rule. And when we have this with parentheses like so, what I do is I multiply the exponents together. So v to the 6 times 3 is the 18th power. Those are all your laws of exponents. Remember, you have this half sheet. Like, do not stress about having to super remember all of them. Hopefully you remember a few of them from 8th grade, but that's your little review there. Let's really focus on the other half of your half sheet, the exponents chart. This is going to be a section of your homework. This is asking us to rewrite our numbers. So in my first one here, I've got 16 with a base of 2. So what it wants us to do is it wants us to rewrite 16, but have the base number be 2. So big 2, look at your half sheet. Do you see a number? Do you see 2 to something equals 16? You should see 2 to the 4th. So if you look at your page, you see 2 to the 4th, that equals 16. Let's keep going. What about 16 with a base of 4? So my big number, think base, think big. 16 with the base of 4. So if I want to rewrite 16 with a base of 4, that'd be 4 squared. 81 with a base of 3, so big 3. I see on my chart 3 to the 4th is 81. 125 with a base of 5. We already kind of did this one. So I'm going to look at my 5 column and I'm going to see that 5 to the 3rd equals 125. And that's one thing we can do. The next thing is 2 a base of 7. So can I rewrite this so that it has a base of 7? So 49 to the 3rd, we have to think 49. What do I have to, what exponent do I have when I have a base of 7 and it equals 49? So 7 cubed, squared, 4th to the 3rd power. I need to find 49 there. So I'm looking at my 7s, and I see that 7 squared equals 49, so I can rewrite 49 cubed as 7 squared to the 3rd power, which then I would use my power of a power rule. 2 times 3 is 6, and that's what I would end up putting in a delta math. So this is just like rewriting what I have. I see it wants it as a 6 to a base of 6. So I'm going to look at my 6's, and I see that 6 to the 5th equals 7,776. But I can't just lose the cubed. So all of it's going to go in parentheses, and I'm going to put a cubed there, and now I'm going to simplify. So 6 to the 5th to the 3rd is the same as 6 to the 15th. Hopefully we're catching on to this. Okay. 256 squared to a base of 2, so I'm going to put a 2. I see on my page that 2 to the 8th equals 256. So I've got 256 squared, and then I'm going to simplify 2 to the 16th because 8 times 2 is 16. Okay, make the bases the same. I've got 5 to the 3x power, and I've got equals 125. So I know that 125 is the same as 5 cubed. I am looking at my 5 column. Make the bases the same. 64 to the 3x power equals 4 squared. I can make 64 into a base of 4 because 64 is the same as 4 cubed. So the 3x power equals 4 squared. This would then become, because I would have to simplify this, 4 to the 9x power equals 4 squared. So that makes my bases the same. Okay. Exponential equations. Here's the rule. Here's what the majority of your homework is going to look like. If b to the x equals b to the y, then x equals y. That's our math way of saying it. Here's the words way of saying it. If they have the same base number, then their exponents equal each other. So, if I'm trying to solve for x, then I would look at this and I would say, well, can I find that and can I rewrite that a different way? Preferably with a base of 7. So I'm going to look at my 7 column and I see 16,807 is the same as 7 to the 5th power. So 7 to the x power equals 7 to the 5th power. And what my rule over here is, if my bases are the same, then I can get rid of the bases and I can say, oh, if 7 to the x equals 7 to the 5th, then x must be 5. And that's kind of how your homework's going to go. We're going to be solving for x like this. Let's try it one more time. 5 to the x. I'm going to look at my base 5s first because that's what I want to find. 15,625, that's 5 to the 6th power. So 5 to the x equals 5 to the 6th. That in turn means that x equals 6. Okay, last one, 6 to the x. So I see in my 6 column that 6 to the 3rd is 216 equals 6 to the x, therefore x must be 3. Okay, so that is the start. Let's flip the page. Here is just using the laws of exponents. Let's try and solve for x. So I see 2 to the x equals 1. Well, I also know that anything to the 0 power equals 1. So I can just say, if x equals 0, then 2 to the 0 would be 1. So that's kind of the thought process there. This was the 0 rule. 7 to the x equals 1 over 7. Well, I know that the negative rule creates these fractions. And if I don't have an exponent here, I'm trying to zoom in a little bit. It's not letting me. That's a secret 1. So if I'd got a fraction and I got 1 over 7, then that means that x would be negative 1, because with my negative rule, if I had a negative 1, that would be 1 over 7 to the 1st power. Okay, also the negative rule. If without a fraction I have 5 to the negative 5th power, then if I had it 1 over 5 to something, that something would have to be a positive 5. Again, this is according to my negative rule. And lastly, 14 to the x power equals 14. Well, if it equals itself, then that means I only multiplied 14 once, like I only put it down one time. So x must equal 1. We're going to use all of this stuff together for the big part of your homework tonight. So Here we go. Here's how I want us to think about these. So notice on your half sheet, you don't have base 36 or base 1296. So I'm going to be looking for these numbers in one section only. And I see, if you look at your 6 column, I see 36 and 1296 in the base 6 column. So I can convert this to 6 squared x minus 2, and I can convert this one into 6 to the 4th. And now that I have the same base, I can do a little bit of math. So I've got 2 times x minus 2 equals 4. And from here, I can solve for x. So I got to distribute. And then I'm going to add 4 to both sides. And then divide by 2 on both sides. And I get x equals 4. Okay, so recap, what I did was I said, okay, I don't have 36 and I don't have 1296, but I do know that they both come from a base 6. So I switched their bases, and now that they're both at a base, at the same base, I can use my rule that we came up with, or that we talked about right here. And because of that, I could solve for x. Let's do it one more time. So I've got 3 to the 1 minus 2x power equals 2187. 3 is really small, so let's see if we can get 2187 to 3. I look at my stuff and I see that 2187 can convert to 3 to the 7th power, which gives me the same base. So that's my first step, is I need to get the same base. And now from here, I can say, I can get rid of the 3's because I know that my exponents are going to equal each other. And I can solve. So subtract 1 on both sides. Let me rewrite it really quick because I ran out of room. And then divide by -2 on both sides. X equals -3. That's what I would put into delta math. Okay. So, I'll do one more. I'll have you try the last one. And then I'll go through it and I'll be done. Sorry, this is a bit of a longer video. 25 and 625 are both really big, but if I look at my half sheet, I see that they both go into a base of 5. So 25 can become 5 squared, -3x minus 2. And 625 can become 5 to the 4th power. Now that my bases are the same, I can cut them out, and I can say 2, -3x minus 2. Notice I'm switching where the parentheses are, because what I'm saying right here, up here, is I'm saying 2 times this whole thing. So as I rewrite it down here, I'm rewriting -3x minus 2 as its own bubble. Even though it's not in parentheses up here, it needs to all stay together until I have properly combined the 2 with it. Okay? And that's just how it's best easiest representation for this. Okay? So, distribute and solve. You can get a fraction, it is okay. So x equals 8 over 6, which can be simplified to 4 over 3, negative 4 over 3. Okay, try this one out on your own. I'll give you a hint. You need to change both of the bases. You need to go down to base 2. So you need to change the 4 and the 512. Okay, take a second, try that on your own. Okay, so changing both bases. The reason I'm doing this is because in your 4 column, you'll notice you don't have 512. So you can't change this to a base of 4 anything because 512 is not a proper conversion. But if I look at my 2 column, 4 is in there and 512. So 4 becomes 2 squared times 3p equals 512 becomes 2 to the 9th power. Now that my bases are the same, I can cut them out. I've got 2 times 3p equals 9. Let me move it up here. 2 times 3 is 6p equals 9. And I divide by 6 on both sides to get p alone. And I'm left with p equals 9 over 6, which reduces or simplifies to 3 over 2. Your calculator can do that for you. Okay. Try your homework out. Email me if you have any questions. Thank you so much.